This distribution is where all the information comes from before we collapse it into these other statistics, okay? So your win rate is just what you get when you sum how many observations do we have on this side of the distribution, how many observations do we have on this side of the distribution, how many trades did you have a positive return, how many negative return. Your expected value is just the mean of this distribution. Okay, but the key to answering all of these much more complex problems, right? Like how much drawdown am I likely to incur? What's the distribution of final account balances after this many trades or this many days? If I approach a prop firm account challenge with this, how likely am I to pass? That all comes from resampling from this distribution in simulation. That's how we introduce randomness to the ordering of trades and explore other outcomes and define these probabilities of more complicated scenarios. We run a simulation where we construct these Monte Carlo equity paths by plucking one trade randomly out of this distribution with a replacement and adding its return here to the equity path, okay? And then we select another one. Maybe we got this one over here. Boom, maybe we got this one here. Boom, this one here. And then we've constructed one alternative equity path here. And then we do it thousands more times, tens of thousands, hundreds of thousands, millions more times. And now we can ask all sorts of probabilistic questions. We can find the probabilities of achieving any ending account balance after a certain number of trades or a certain number of trading days. We can find the probability of incurring any amount of drawdown or any amount of run-up a certain number of trades or days into trading the strategy. We can simulate barrier problems like a barrier option or a prop firm account challenge and find our exact probability of passing. So this is really the uncollapsed information from a backtest or a list of historical trades.